Sorry, I got a phone call regarding this part. Never mind, it's I think more complicated than this one. Over here I have a party of cotans. Let me take them all in one side. So I'll have cotan squared theta minus cotan theta equals to 0. So I can start taking cotan theta as a common factor. So I'll be left here with cotan theta. Oh, actually the question was cotan cubed. Okay, so I'm left here with cotan squared minus 1 equals to 0. Okay, so one option, either cotan theta equals to 0 or cotan squared theta equals to 1. So when is cotan theta equal to 0? When tan is undefined. When is tan undefined? Tan is undefined over here. Anyways, cotan is x over y. So 0 over 1 or 0 over negative 1 will give you 0. So how will I write that? I can write it as pi over 2 plus n pi because it repeats itself every pi. So pi over 2 plus n pi. I'm left with this piece cotan theta is equal to plus or minus 1. طيب زي التان بالضبط at every quarter. So here cotan theta is 1, here cotan theta is negative 1, 1, negative 1. So I can just write pi over 4 plus pi over 2n, or plus 90, 90, 90, 90. So theta is equal to pi over 4 plus pi over 2n, and these are the only possible answers. You can substitute and try. I can see I can take a common factor as sine. I'll take this sine cubed theta minus sine squared theta. The first step is to drag all the trigonometric functions and everything to the left side and set it equal to 0. This is the easiest way. And then I'll take sine squared theta, common factor. I'm left here with root of 2 sine theta minus 1 equals to 0. Yeah, I have two options, either sine squared theta equals to 0, which means sine theta equals to 0, or root of 2 sine theta equals to 1, which means sine theta equals to 1 over root of 2, or root of 2 over 2. Okay, sine theta is equal to 0 right and left. Okay, so I can say at theta equals to 0 plus pi n, because it repeats itself every pi. And for this one, when is sine equal to root of 2? Only in quadrant 1 and in quadrant 2 and at the quarters. هنا وهنا. Okay, so one of them I will write as theta equals to pi over 4 plus 2 and pi, because it will come back after 360, and the other one is 3 pi over 4 plus 2 and pi. Okay, that's it for question number 9. Question number 10, cosine squared sine theta equals to sine theta. Okay, for question number 10 there are extraneous solutions. يعني في solutions هتطلع, بس when I come to substitute them I find that they are not wrong, but that they are wrong. I'm sorry, they are wrong. Anyways, I would start with cosine squared theta sine theta minus sine theta equals to 0. If you take sine theta as a common factor, you will have cosine squared theta minus 1 equals to 0. Either sine theta equals to 0 or cosine squared theta equals to 1. Sine is equal to 0 at 0, and sine theta, actually sine theta is equal to 0 is at 0 and at pi over 2, right? At pi, sorry, 0 and pi. By the way, there are no extraneous solutions, I guess. Maybe I am wrong. Anyways, هنا هيطلعوا لي 0 and pi, and because it's endless I can just write pi n. N can be 0 or 1 or 2 or 3. It keeps repeating itself every pi. For this one, cosine theta is equal to plus or minus 1, and unfortunately they are the same answers again, because cosine theta is equal to 1 here and negative 1 there. So 0 and pi, so it repeats itself every pi n. So it's the same answer, and no, it's not this question that has extraneous solutions. We don't have any in this book, maybe. Regarding question number 11, I have to work on this, changing it to sine. Okay, better for me. So 2 and 1. Maybe someone else wants to work on this side and make it cosine 2 theta. which is also possible. I can show you that too. So over here 1 minus sine squared theta equals to 1 minus 2 sine squared theta. So 2 minus, sorry, this is a 2. 4 sine squared theta minus 1 plus 2 sine squared theta equals to 0. So I can say I have a negative 2 sine squared theta, or I'll take them to the other side. 2 sine squared theta equals to 1 sine squared theta equals to half sine theta equals to positive or negative root of 2 over 2. If I root them, I will have root in the denominator, and then I will rationalize and so on. Okay, any positive root of 2 over 2, so it's pi over 4 plus pi over 2n, because it repeats itself every 90. كل الكوارترز يعني and forever. If you did like Lamar, she started by, I think, this way, cosine 2 theta equals to cosine 2 theta, yani she worked on changing this. Okay, I will show you. I can do that. I can do 2 cosine 2 theta minus cosine 2 theta equals to 0, and take a cosine 2 theta common factor. I'll have 2 minus 1 equals to 0. So probably anyways this is going to be 1, or I can just subtract. I will get 1. So cosine 2 theta equals to 0. So when is cosine equal to 0? Cosine is equal to 0 at pi over 2. طيب, and because this is 2 theta, actually it's at pi over 2 and 3 pi over 2. طيب, anyways, because this is 2 theta, so I can say that theta is equal to pi over 4. Okay, and pi over 4, and what is the period of this function? Here, because it's 2 theta, the period will become 2 pi over 2, or 2 pi over 2, which is pi. Okay, but anyways, it's gonna repeat itself every it will repeat itself every pi over 2n. Again, I have 2 theta equals to pi over 2, or 3 pi over 2, as we said. This is where it's equal to 0. So this is pi over 4, or if you divide 3 pi over 2 by 2, it will become 3 pi over 4. You can see the difference between this and this, that I added a pi over 2. Okay, then from here to there, pi over 4 and 3 pi over 4. Actually, now I cannot show you the unit circle much, because this function is cosine 2 theta and it's not like the normal one. And anyways, theta is equal to pi over 4, and it's repeating itself every pi over 2. And for this question, sec squared theta, okay, I will just root directly. So sec theta is equal to positive or negative root of 2. And when does that happen? It happens when you can change it to 1 over cosine if you wish, but actually it happens at where the cosine is root of 2 over 2, positive or negative. Yani if you change it to 1 over cosine theta equals to positive or negative root of 2, and you swap 1 over root of 2 plus or minus equals to cosine theta. And this happens every quarter, so pi over 4, and it repeats itself every pi over 2 n, whatever the number of n. Okay, for question number 13, the question is saying solve all the values of theta in degrees, for all values of theta, but they want the answers in degrees. Okay, so question number 13, again they're all repeated and all similar ideas, and it keeps repeating itself. You get adapted to doing this. And then take cosine theta as a common factor. Sine squared theta minus 1 equals 0. Either cosine theta equals to 0 or sine squared theta equals to 1. Cosine theta is equal to 0, up and down. So at 0 or 180 degrees, they want the answers in degrees. Okay, and over here sine theta is equal to positive or negative 1, and this happens every up and down, so 90 or 270 degrees, right? So if I have an answer at 0, so I have an answer at 0 and at 180 and at 90 and at 270. Okay, I can write the answer finally as 90 plus 180 n. Just a second. actually I think these I think if we try the zero is extraneous, it's not right. Let me just try sine 0 squared times cosine 0, right, squared times cosine 0 minus cosine 0, that's not equal to -1. 0 is not an answer. And if I try 180, I got them all to the left side, and I'm checking if they will equal to 0 or no. 180, and over here 180 also will not equal to 0. These two answers are not accepted, only these are accepted, okay? And that's why I wrote 90 plus 180, and if you try these, they're not right. 90 plus 180 means 90 and 270 and more of 180 to go. This one's ready for you to directly factor. So cosec theta and cosec theta, it's ready made for you hatta this time, and I think I need a 2 and a 1 and both of them negative, equals to 0. Okay, so either cosec theta equals to 1 or cosec theta equals to 2. So 1 over sine theta equals to 1, 1 over sine theta equals to 2. So sine theta equals to 1 or sine theta equals to half, right? Sine theta equals to 1 again every 90 degrees. I'm sorry, no, it happens only, 1 is only at 90, so 90 plus 360, and sine theta is equal to half at 30 or at 150 in quadrant 1 and in quadrant 2 only, plus 360 and plus 360, and you can find them all on the unit circle. Regarding this question, I think I did multiplication here, so 1 equals 4, 1 minus cosine theta, 1 plus cosine theta, so 1 equals 4, and these are difference of squares, so it can be 1 minus cosine squared theta. How? First with first, last with last. 1 minus cosine squared theta is sine squared theta, and I don't think I need that anyways. Equals to 4 minus 4 cosine squared theta. We can do that. Maybe I can handle it with the cosine. Now I don't have any other trigonometric function, so if I take up here this over here, I'll have -4 cosine squared theta equals -3. So cosine squared theta equals to 3 over 4. So cosine theta equals to positive or negative root of 3 over 2. Okay, again on the unit circle, the root of 3 over 2 is at 60 degrees and at 120 degrees plus 180n, and I'll tell you why did I choose 180n and not 360. Every root of 3 over 2, there is one root of 3 over 2 over here, okay, and if I add 180, I'll get dragged to this one, which is at 60. This is cosine. Cosine root of 3 over, wait just a second, they said cosine is equal to root of 3 over 2, right? Cosine theta, so cosine theta, so it should be 30 actually, not 60. Why did I get a 60? No, it shouldn't be a 60. So root of 3 over 2 happens here at the 30, and again at the 240, and it happens at what else after that? Root of 3 over 2 cosine here at 150 plus 180, because it will after 180 degrees I will be here also. Actually here around the 180 اللي هو من هنا لهنا, this is a 180 degrees, so 150 and 330 also cosine is root of 3 over 2. So I would say this is a 30 and a 150 degrees actually, right? 150 plus 180, and I will double check this question when I'm done with the video. So I don't know, I think the answers in the book were the others. I will substitute and check. Question number 16. Okay, I can just take this over here. It's root of 2 cosine squared theta minus cosine squared theta equals to 0. I can take cosine theta as a common factor, or cosine squared theta. Here we'll be left with root of 2 minus 1 equals to 0. So actually cosine squared theta, this is question 16, cosine squared theta, if I take them here, 0 divided by anything is going to be 0. So cosine theta is equal to 0, and cosine theta is 0 at 90 plus 180 n. Okay, now here these questions, they just said solve each equation, and they didn't mention they want in degrees or in radians wala interval. That means I'm gonna get all possible answers, and I'm gonna get them in degrees and in radians. I can say sine squared theta equals to 3 over 4. So sine theta equals to positive or negative root of 3 over 2. These are the ones that are 60 and 120. So 60 plus 180n, or 120 plus 180, and because it will repeat every 180, it will repeat itself. Or you can write it as pi over 3 plus pi n, and this one is 2 pi over 3 plus pi n. So I'm gonna write the answers in degrees and in radians. This question is easy. 4 sine squared theta equals to 1. Sine squared theta equals to 1 over 4. Sine theta equals to positive or negative 1 over root of 2, which is positive or negative root of 2 over 2, and this happens every quarter. Anyway, I can write the answer as 45 degrees. 45 degrees. 1 over, not root of 2, I'm sorry, 1 over 2. Root of 4 is 2. So positive or negative 1 over 2, and this happens at 30 degrees. And comes again at after 180n, and it happens at 150 degrees plus 180n, or you can write this as pi over 6 plus pi n, and this one as 5 pi over 6 plus n pi. When is sine positive or negative half? At the over 6 things, or this one at pi over 6 and 5 pi over 6 and 7 pi over 6, and this one 11 pi over 6. So if I say pi over 6, I would say plus n pi. It would drag me to this one. Okay, that's in the same place if I draw a straight line. And the 5 pi over 6 also plus 180 would drag me to this one. So instead of writing this plus 2n pi and this plus 2n pi and this plus 2n pi and this plus 2n pi, I can do that. I just take the 30 and the 150 and say plus 180n. Okay, we have 3 questions left finally. So for this question, it's ready-made for you. I would factor 2 sine theta, sine theta. Oh, okay, but firstly I'll take a plus 1 here, right? And sine theta. To get a plus 1 over here, I think I need a minus 1 here and a minus 1 there to get a minus 3 over here, equals to 0. Either sine theta equals to half or sine theta equals to 1. Sine theta equals to half at 30 degrees plus 360n, or at 150 degrees plus 360n, because it's not plus and minus, it happens twice only. Or you can write the answers at pi over 6 plus 2n pi, or 5 pi over 6 plus 2n pi. Sine theta is equal to 1 once only at pi over 2 plus 2n pi, or you can write it as 90 degrees plus 360 degrees. And for this question, I can change this one to 1 minus 2 sine squared theta plus sine theta minus 1 equals to 0. This cancels this. I can take sine theta common factor outside. I'll be left here with minus 2 sine theta plus 1 equals to 0. So either sine theta equals to, sine squared, it's not 1 minus 2 sine squared theta. Wait, this is number, yeah, I'm right. Sine theta equals to 0, or sine theta equals to negative 1 over negative 2 will be half. Sine theta is equal to 0 at 0 plus n pi, or you can just write n pi, or you can just write 180n. My pen is gone. And sine theta is equal to half at sine theta is equal to half at pi over 6 plus 2n pi, or 5 pi over 6 plus 2n pi. And pi over 6 is 30. You can write it as 30 plus 360n, and 5 pi over 6 is 150 plus 360n. You're expected to write the degrees every time. I'm sorry for the camera. For question number 21, they want the midline. Remember when I told you the midline is where the graph oscillates, and this function is called h equals to 2 sine x, and it has an amplitude 2. It's a function, just a sine function with an amplitude 2. So over here it's 2, and over there it's -2, and I'm going to rise until 90, and then drop at 180, down at 270, and then come up at 360, and so on. And this is the midline over here. So they want an equation for the midline, that this midline here, it's 180, and then 180 times 1, 180 times 2, or 180 times 0. This line can be just called 180n. Or you can write the answer as pi n. This is the line. I can call it I don't remember what the question was asking exactly, but the answer for the midline is 180, and that's it. Bye.